Hello, my friends, and welcome to another fabulous episode of the AI Show. My name is Seth, and I'm so excited that everyone is here today. Let me turn my voice up a little bit so you can hear me. We've had a little bit of a hiatus, well, at least for me. We had a holiday here in the United States, and I did a pre-recorded show. Hopefully, y'all enjoyed it. We've got some of the nuggets of some of the past episodes, and then last week you had Aishigul and B. They are awesome. They are also going to be here next week, Friday at 11 a.m. Pacific time. I mean, I feel like it's a fine Friday thing to do. And if your boss comes around and is like, why are you watching videos? Just tell him. Just tell him. Here, let me, we're going to make it super. I'm learning. Just tell him that. This is a Microsoft show, and I'm learning how to do AI. Yeah, tell them that. For the next 2 hours, we're going to have a little bit of fun. Let me tell you a little bit about what we're going to do. Let me share my screen here. Let's get this on there. This is my screen. There you go. My screen. Look at this, huh? I can do this now. Huh? Which one do you like better, this one or this one? This one or this one? I'm going to do this one. All right, as we get started here, where's everybody coming from? Let me unhook my pandemic purchase here. Let me look at the comments here. Where's everybody coming from? Saludos desde Monclova, Coahuila, Mexico. That's beautiful. Thanks for coming. We should do an AI show in Spanish only. You know what I'm saying? We should do an AI show on Spanish. All right, so today, we're going to do a couple things. Maybe I'll invite people to come talk about stuff too. For sure, we're going to be doing number one. Oh, I don't like that color. I don't like that color. Let's fix it. Hold on. Let's fix it. Okay. No, that's not what I want to push. This. Okay. So number one, we're going to be talking about our AI dashboard things. So this, if you don't know what this is, responsible AI. That's what we're going to talk about. Mehrnoosh and Besmira are here. We recorded something earlier. We're going to show that to you if you haven't seen it. And then you get to ask them any question you want. Like if it's about life or your sourdough starter, I'm sure they'll have answers to those questions as well. No pressure. Am I right? Number two, I got a new machine. And so, my handwriting is terrible. I should have been a doctor. Got a machine. So we're going to see if Rochambeau still works because I tried to install everything. Rochambeau. And I think we left off with an endpoint that we can call. So we can hopefully get in that. Because remember, we tried very hard to just write our own JavaScript conversion of our image into vectors, and I didn't like doing that in JavaScript. I'm gonna be honest, I felt dirty about it. It needs to be done in Python for me. I mean, maybe I'm biased, but it's what you get. All right, and then number three, we'll do some planning. Oops. No, that's not what I want. Planning. Why did it do that? Someone else tried it. We'll do some planning and see what we want to do with Rochambeau. Look at that, that's terrible. I'm not even trying anymore. It's like I'm not even trying, friends. All right, so where is everybody coming from? Make sure to put it in the comment section. I know someone from Mexico is already here. Wonderful. I love Mexico. If I may, I am far north enough to know that some of my peoples, because I'm Mexican too, did not make it up here. And the Mexican food game here is just not good. I'm just going to put it out there. Yogesh from India, welcome, my friend. India has wonderful food, incidentally. The last time I was there was like, I don't know, 2 years ago. The last time we were anywhere was 2 years ago. Blanding, Utah. Oh, it's my friend Travis Watcott. Oh my goodness. Like, he knows me before I became a technical guy at Microsoft. Hey, Travis, it's good to see you. Oh, my wife's looking at me. What's up? She's like, no. I'm doing my show. Is that okay? Yeah, she's like, Travis. Yeah, Travis. He came in as looking on in LinkedIn. Okay. All right. Welcome, friends. Again, Rajesh from India. Thank you. It's probably late there. Mario, welcome. All right. So I'm going to turn this music down so it's more background music. So those are the three things we're going to be doing today. I am hoping that we spend a lot of time, because we already recorded the thing here. We're going to show it to you, but have questions, because a lot of people, we talk about AI as if it's like some magical thing. It's not magical. And then once you understand the implications of what it's actually doing, then you're like, oh, we should be responsible with this stuff. And yes, you should. And so that's what we're going to talk about today. All righty. So let's go here. Let me bring my guests on. Hopefully they're ready. Besmira's not here yet, but she'll come soon. Oh, there she is. Hi, Mehrnoosh. Hi, Besmira. How are you, my friends?
Hello.
Doing great. How are you?
Any fun holiday things that you did?
Can you go back?
Can I think for a minute?
Everyone's like, well, we basically sat around and watched Netflix. I did too. Not gonna lie, right? It's probably one of my favorite things. What about y'all? Any fun things that you did over the holiday here?
Well, one thing I did was I set up the very first Christmas tree in our household for the first time after being in America for almost 9 years. So that's very exciting.
I never really did that until I had kids, because it's like, and then it's like stays up until sometime in March, and you're like, I should probably take that down. Now, is yours like a tiny tree, a big tree? What?
Oh, that's a big tree, and I already have nightmares about the moment that I need to bring it down.
Just leave it up. I mean, you'll have to put it up. It's like my kid says, why do I have to make my bed? I'm just going to mess it up later today. It's a good argument. What about you, Besmira?
Actually, we realized Mehrnoosh and I did the tree almost at the same time after the release of what we're going to talk about today. Literally, after it was done that day, we both did the tree independently. There was no correlation.
Yeah, well, I think because, I mean, people don't know this, but we had a responsible AI event. I think it was on Tuesday. I participated a little bit. It was fun. But you spent a lot of time getting ready for it, if I remember right. Yeah?
Yeah.
That is correct.
And therefore, the tree had to come after.
The tree had to come after.
Yep.
What we used to do, and maybe I shouldn't say this, but what we used to do a while ago is we would get real trees, and I lived in the desert. Mm-hmm. And so after we were done with the tree, we'd take it out in the desert and set it on fire.
Okay. Kind of like, what's that party that happens in the desert and there's some fire involved?
Oh, Burning Man.
Burning Man.
Oh! So we basically invented Burning Man as children.
Yeah.
Thank you, Besmira, for that.
Yeah.
All right, so let's do that. Let's do this. Maybe you all can give us a little bit of a preview. Responsible AI. What are we going to look at here in a second? We'll start with you, Besmira. Just if you can give like a summary, Besmira, and then you, Mehrnoosh, we'll pick up anything she didn't mention, and then we'll show what we built, and then we'll take questions. All right, go ahead, Besmira.
Yeah, we're going to introduce the Responsible AI dashboard, which is this single pane of glass to responsible AI. This is an effort that we did to bring together different pieces of tooling and visualizations and insights on responsible AI.
Oh, okay. Very well put, Mehrnoosh.
I just want to add that many of you have heard and will continue to hear about responsible AI. And one challenge for that is, okay, I understand that these principles in theory are important, but how can I implement it in my ML lifecycle? And that's where this dashboard comes to help you to implement all of those kind of like buzzwordy stuff in practice and make it part of your ML lifecycle. So we're very excited to bring it to you, actually.
Fantastic, and that's the one thing that I like the most. I love the summary, Besmira, and then you taking it home, Mehrnoosh. It's actually practical things you can do with models, and we talk about AI models here. We'll probably look at one, and it's just the reality is you kind of have to know what it's doing when you're releasing like functionality to be constructed automatically from data, and I really like that. All right, so let's do this. Let's go ahead and get ready to play it. And then those that are watching, feel free in the chat to just get all your questions in during, and then we'll answer every single one of them, even if it's AI specific. Besmira is you work in Microsoft Research, right?
That's correct. Yeah.
And Mehrnoosh works in the AI product group. We're on the same team, so I'm on her team basically. That's how we think about it. And so we have people from the implementation side and the research side. So get ready. I think it's going to be a good episode. All right. So let me do this. Let me go ahead and get ready to play it. Starting right. I don't want to miss this episode of the AI Show where we talk about the Responsible AI Dashboard, a one-stop shop for operationalizing responsible AI in practice. Make sure you tune in. Hello and welcome to this episode of the AI Show. We're talking about Responsible AI Dashboard, the Responsible AI Dashboard, a one-stop shop for operationalizing responsible AI in practice. And we're pleased to welcome back Besmira and Mehrnoosh. Hello, my friends. Why don't you introduce yourselves? We'll start with you, Besmira.
Hello, it's great to be here. I'm Besmira. I'm a researcher at Microsoft Research working on responsible AI, reliability, robustness for machine learning. And we collaborate with a fantastic team at Azure Machine Learning to create tools together.
Fantastic. Mehrnoosh.
First of all, thanks for having us back in this show. Always a pleasure. My name is Mehrnoosh Simeki. I'm a senior technical program manager under Azure Machine Learning. Just like Bessa said, we always collaborate with Microsoft Research to bring their latest and greatest in the space of responsible AI and create tools that help operationalize the buzzword responsible AI in practice.
Fantastic. So last time we had you on the show, we talked about error analysis, and I thought about it a lot afterwards, and it felt like that was a part of a larger responsible AI thing. What more things am I missing? We'll go with you, Besmira.
Right on point, Seth. Actually, in the last 6 months since when we talked together, we started this initiative for bringing responsible AI tools built at Microsoft and in the open source together as an integration effort. And there's a question of like, why did we do this? In many studies that we have run in the past 5 years, we have seen that machine learning engineers, data scientists, sometimes their work gets clunky and complex just because these tools stand in different places. It's hard to exchange results and insights and visualizations among these tools. And then there's an issue with discoverability and adoption. If you have to learn 10 different tools in order to operationalize responsible AI, then the learning curve is a lot higher. So then we thought, okay, so there's all these mature tools that have been built so far. There is a very nice story about how do you use this all together in order to debug your models, to make responsible decision-making. And we started this effort that sort of integrates them into a single dashboard and flows all the insights. And Mehrnoosh is going to show you later in a demo, so stay tuned for that. On how these results can flow and how can one deep dive into model debugging and responsible decision-making. There's 2 areas that we tackle in this tool. One of them is model debugging, and we talked a little bit about that in our analysis, but there's many aspects to model debugging. You know, there is error identification. When you start finding your errors, there's a diagnosis part that needs other types of operations that are related to data exploration or to model interpretability. There's a strong fairness aspect that is related to model debugging to really understand the metrics and how errors are distributed, counterfactual analysis, and all the sorts of things that maybe, you know, other practitioners will want to build in the future. And then the very new thing that we are integrating in this dashboard is responsible and business decision-making. It's true these days that there is a lot of data lying around. We want to take responsible decisions in the real world. Correlational analysis is not sufficient for taking such decisions because we may rely on spurious correlations, things that maybe are there in the data, but if you change them, nothing happens in the real world. So based on mature tools like EconML, we built this dashboard that integrates and makes it easy really to take decisions.
So this is awesome. The way I'm hearing it is there's like the programmer and technical component, I guess, of the actual model, debugging, etc. And then there's the business aspect of like, what is this actually doing? Am I dividing these things up correctly?
Oh yeah. In terms of user audience, that's exactly.
So to me, it's always hard to visualize a tool that can do both. Mehrnoosh, can you show us what this looks like?
Absolutely. Let's do this. So first, I do have a model which is trained on top of the Kaggle apartment data. And this is a classification model that predicts whether a house would sell for more than median or less than median. And you can imagine that if you make a mistake there, for instance, if you make a mistake and predict a house to be selling less than median or price it in an incorrect way, then that can impact the actual sale that the homeowner will take home, and so kind of like cause financial loss, and also can limit the ability of that person, that house owner, to access finances from a bank. So it is quite important to make sure that this apartment pricing prediction model is getting it right. So I'm going to start with my model debugging. And Seth, when you open this dashboard, the very first stage is for you to identify the model errors. And so I start with the piece that is familiar to you from the last time, which is error analysis. And for instance, here, I can see this error tree that the error analysis has automatically trained on top of my model predictions, and can, for instance, see that I do have some bigger, older houses for which the model is making 24% error rate compared to the base rate of 11, and 75% of overall errors in the tree are happening here. So this is actually a great blind spot that I just discovered, and I can save that just so I can take it to the other stages and explore it further. In contrast, I do have this one, which is a cohort for bigger, newer houses, and as you can see, the error rate is as low as 6%. So just for contrasting purposes, I saved that also as my one cohort. And just bear in mind that the same heat map capabilities that error analysis was covering could also be used here. So that's another way of you identifying errors. For instance, you want to bring one feature here and kind of like investigate how the errors are distributed across, say lot frontage in this case. And similarly, you can click on any of these grids and save that. But for simplicity, I just stick with the error tree. I created 2 cohorts, and now I would like to move forward with data exploration, model stats overview, and model interpretability to explore.
So let's pause right there. If you could scroll up, because I want to make sure that I'm understanding this, because you explained it last time, but I want to make sure I'm getting it. So basically, the 570, the 730, that's the number of examples you're giving to the training algorithm. Is that right?
That's the test data, basically.
Okay, so test data, cool.
Exactly. So now it tells me that overall, out of 130 data points, 87 of them are erroneous. And then like suddenly that ratio becomes quite off for the bigger, older houses.
That makes sense. So this is basically saying on the test data, it's dividing up the errors by the actual features. So I can see what features are causing the most errors. And I think when you highlight over the 66 over 271, it's telling you it's telling you the exact feature and where the break is in this particular model. Is that right?
Exactly.
Okay,
That's
cool.
correct.
So now that you've done this, like as a debugger, it feels like, okay, I've got a good sense of what's going on, but you wanted to show me the next bit, which was it called the model statistics?
Correct.
If we can scroll down.
So
How is that different?
So here's the problem here. First, we helped you identify the error, right?
Right.
But now you want to diagnose it, because you can't always jump from identification to coming up with your mitigation strategies. But if you don't know why that issue is happening, it's actually quite difficult for you to go and fix it and have a targeted mitigation step. And so we have implemented other things like data exploration, where, for instance, you can understand that certain erroneous cohort and see whether there is some underrepresented cohort there that you need to go and enhance. Or, for instance, you can look at model interpretability to understand why the model is making predictions for that cohort, and whether for erroneous cohort, the model is depending on some other features compared to the rest of the cohorts. So now we are entering that diagnosis land, where I'm going to show you how we can use the other capabilities of this dashboard in order to understand why things are going wrong and help us take targeted mitigation steps.
Let's do it.
Great. So first, as you said, we come to the model statistics page. And what I am seeing here is I do have these cohorts that I saved and I brought up transferred here. And right off the bat, what I'm observing is, and there's also one unsaved because I clicked on the demo or on the cohort, but the y-axis or the x-axis here is the prediction probability of less than median. And right off the bat, you can see that for the old houses, you're getting a lot more higher probability of selling less. And the results are much more accurate for newer houses compared to the older houses. So that's something that I would like to explore based on looking at the underlying ground truth data to see, am I representing something differently in old houses versus newer houses? So I come here to the Data Explorer, and this is basically to help you do exploratory data analysis. And imagine I want to show you the ground truth values. So actually in my ground truths, how many houses did I have with like actual ground truths of selling more than median versus not. And for newer houses, as you can see, Seth, here, the actual new houses are more probable to sell for more than median. So all of my representation in ground truth data had actual more than median prices. And so even if the model randomly says all the new houses to be more than median, probably it's going to achieve a higher accuracy. Versus for my old houses, I do not have enough representation of old and expensive houses. So that's what I mean by diagnosis, because now I just diagnosed that you need to go and collect more expensive older houses and retrain your model just so the model can learn about those type of houses as well.
So let's scroll up because I want to ask a bunch of dumb questions because, you know, it's me. So let's scroll up to the box plot. These are called what are these plots called? Box plots?
These are box plots, and these are basically tell you what is the median, 25th percentile, 75th percentile. So basically, this is now showing you the distribution of prediction probabilities and towards the list price. And so as you can see that the new houses, they have lower distribution towards less than median. So actually they're predicted to sell for more than median versus for older houses, that's not the case.
I see. So this here is telling us, because if you scroll down, these are the probability, well, I'm going to say quote unquote probability distributions of if it's less than 0.5, we're going to guess, you know, this. And if it's greater than 0.5, we're going to guess that. And we can see that new and old houses distribution wise are predicting on the opposite side. Exactly. And when you scroll down, you're saying, okay, let's look at the data. And what you've noticed is that you had an imbalance in data that has those particular features.
Exactly.
Okay.
Exactly. That is absolutely correct.
Cool. All right. What else you got? I mean, because it feels like now I'm done, right? I know that the problem is I need to collect more. I need to collect more of the older, expensive houses to get a better balance. And that's it, right? Is there anything else I need to do?
You can also learn a lot more about how the model is making its prediction. And so I just get rid of this unsaved cohort and stick to my old data, old houses and new houses. And so the thing that you can see here is first the global explanation, how the model is making its prediction for the whole data across these cohorts, and also individual feature importance. And the way that it is important here is, first of all, I can see for my old data, these are the top key important factors: overall finished quality, above ground living area, total basement square footage. And I can also see like other types of things. And so for instance, I can see that year built is a lot more important for new houses than old houses. So suddenly the fact that a house is newer, that becomes an important factor in predicting whether someone or the house is going to be selling or predicted to sell more than median or not. So you can kind of like compare how the model is making predictions across these different cohorts. You can even see how that model is doing that. So like how the model is using the overall finished quality by clicking on it in order to make its prediction. And so what this chart is telling you, and each of these data points is for one house, but what this chart is telling you is how the overall finished quality is impacting the prediction of less than median. And so for the higher overall finished quality houses, that becomes that high overall finished quality becomes a negative indicator towards the less price, versus if the house is actually lower quality, then that factor becomes a positive indicator of that house is going to be predicted to have a lesser price.
That's interesting. And so basically, I mean, this is like becomes a human version of the model where you're basically going in and saying, oh, wow, I've just learned a lot about this just by making a model. I don't even have to put this into production, but maybe I've learned something that I shouldn't put this into production, or I've learned something about the actual market.
Correct. And so imagine like if neighborhood, which is highly correlated with ethnicity, was showing up as like one of the top two features, then you want to go and investigate more. You want to make sure that the model is not causing any fairness issues or harms for people being represented from different neighborhoods. And so that's how you can kind of like see, oh, is my model making its prediction based on the factors that make sense? Or is that just depending on some correlations, spurious correlations that are totally random?
Got it. That makes sense. What else you got in there?
So besides this aggregate feature importance, you can also investigate individual data points. So for instance, the cohort that I had up, I can first of all see how many correct and incorrect data points. I can take a look at them. I can click on one or multiple of them and compare the individual feature importance values as well. So this is the like individual house. So for Mehrnoosh's house that has been predicted to be selling less than median, why is that? What are the top key important factors? So it's actually a lot more targeted debugging for, say, Mehrnoosh's house, Seth's house, Besmira's house. And so that concludes our feature or model interpretability. And that takes me to another factor, which is also about diagnosis, which I call counterfactual analysis and what if.
Okay.
And the way that one works is, say I click on an individual data point, and what that shows me is, first of all, I can then create counterfactuals. Then let's open the buzzword counterfactual. Counterfactual data points are telling me what is the bare minimum change I can apply to that house, that Seth I just clicked on, which actually has a very high probability of getting the less than median prediction. So actually that is predicted to have a lower price. Mm-hmm. And what is the bare minimum change I can apply to this data point, to this house, in order for the model to predict the opposite class, which is actually predict a higher than median. And so if I now look at that, it's like, oh, if this house had a higher overall finished quality from 6 to 9, keeping all other features constant, then that house would have got a prediction of the opposite, which is higher than median prediction. And that's another way of first checking for some fairness issue that can creep into your model. Because if, imagine a loan scenario, if my counterfactual, my loan has got rejected by the AI, and my counterfactual is if that person had a different ethnicity, then that person would got the loan, then that's a major fairness issue.
Oh, yeah.
And so that's why we say this is an important debugging tool, but also it's great for customers in terms of decision making. Say my loan has got rejected and I go and say, or let's say this example, my house has been predicted to have a lower price in the market, and I want to know what to improve in my house as a homeowner in order to get a better outcome from that prediction model. Then you can say that, oh, if you improve your overall house by like from 6 to 9, then that's when the AI is going to predict the opposite for you. And of course, you can do like free-form what if analysis as well.
So let's pause right there. So let me see if I understand it. So this counterfactual feature, what it does is it, because I thought you were going to perturb the things until you found it, but it actually figures out on its own, what can I change to make it predict the opposite in the least amount and the least destructive way. So you just changed from
Exactly.
6 to 9, and then it's over. And then there was other examples. Is that right?
You got it absolutely right. And if it's a regression case, then it says like, give me a different range, and Counterfactual automatically shows you what to do with that data point to land the prediction in that opposite range.
So this is really cool. And this all feels like the developer model builder type of thing. But Besmira mentioned the business aspect of it too. And I think you might have hit on it a little bit, but can you dive into like, how can I make business decisions now based on these models?
That's a very great point. Absolutely. And so inside the dashboard, you do have causal inferencing capabilities as well. And there are 3 different capabilities. So let's unpack that. There is no model here, Seth. So it's just historic data. And I'm a business stakeholder from this company, this housing company, and I want to provide either house sellers, house builders, developers, and individual house owners with actionable insights as what to do in order to really change the price of their house in the market. We're not talking about the model, we're talking about historic data and whether we can do some causal analysis to provide them with that advice. And so now I'm looking at 3 different capabilities here. First is aggregate causal effects. And the way that works is I passed a couple of features to this part of my dashboard as my treatments. And so I own a bunch of houses and I want to know, like on average, how increasing the number of garages or increasing the overall finish quality by 1 unit would impact the actual housing price in the market. And so this is giving me that kind of like view on all the data in this data set, and also gives me the confidence interval. But you might be an individual house owner and you might say, but what about my own house? And so imagine I now click on Seth's house, and then I can see for Seth's house how changing then if he goes and builds 1 more garage car, or if he goes and improve the overall finish quality by 1 unit, how much that would impact the actual housing price. And in this case, these are in K, so 43K if you add 1 more garage car, and 38K if you improve the overall finish quality by 1 unit. And you can even do causal what if, which is don't mix them with prediction what if. Prediction what if says how changing a factor would impact the model prediction, but causal what if says, if I increase the overall finish quality of this house from this to say another value, how would the actual price change in the market? So from 196K to 218K.
So here's a question. Before we go on, and I'm sorry to interrupt because I'm learning a ton here. You're saying this is not coming from the model. Is this coming from pure statistics? Because I'm seeing like z-scores and p-values. Is it just doing an analysis over the entire data set and then using that the probability theory to generate the numbers?
Correct. So this is actually backed by an open source package from Microsoft Research called EconML, which depends on a technique called double machine learning to take out this spurious correlation and exactly give you what you need, which is what is the causal effect of one factor on an outcome and with what confidence. And that's purely based on statistics. There is machine learning, but don't mix that machine learning with the model that we just showed you and we just debugged.
Because that's just specifically for this model.
Exactly.
Here's what we've learned. But if you want to learn specifically from the data side, from a business perspective, here's what you can learn. Let's take out the spurious correlations or the ones that cause, p-values to not work or z-scores to not work. This is what will happen if we make these kinds of changes. Am I close?
That is absolutely true. And one other cool thing about this dashboard is you can even get, like, imagine you're a house builder, so you have a bunch of houses and you want to know how to treat these houses in terms of either shrinking or removing or adding more screen porch. And so it even gives you that ideal policy that will lead to the biggest boost in your overall data points or overall housing market. And so it tells you that, if the overall condition is low and the basement unit square footage is small, then shrink or remove that screen porch, versus for some other cohorts you can actually expand it. So this is also quite cool because we can go ahead and treat everyone the same by like expanding the screen porch, but this is giving me that if I go ahead and expand the screen porch, that's how much gain I'm going to see on average on my housing price. But if I go with this recommended policy, that's how much gain I'm going to see. And imagine how it's helpful for marketing and sales scenarios, right? Like you have all these customers, imagine for your business, and you want to improve your sales or whatever else that you want to boost in your business. And this part is giving you customized policy treatments as, oh, maybe for this cohort, go and provide discount. For this cohort, keep the pricing as is. And so it can give you like a lot of targeted mitigation, action items as how to treat your market.
That's really cool. And it's not model based, it's economics based because of
Exactly.
econ ML. This is really cool.
Right.
So we've talked a lot about, error analysis. We've looked at the data in aggregate. We've looked at the data individually. We've looked at the data as perturbations and counterfactuals. We also looked at, just the data from not the ML side, but from the economics side. And one of the things that's missing is this notion of fairness. Can you tell us about that?
Absolutely. So I tried to mention a couple of fairness type of issues that you could identify with error analysis and interpretability. For instance, if you see that in your counterfactual, the thing that is causing your counterfactual is a sensitive attribute, that's a fairness issue. If you're seeing your sensitive features or features that are very correlated with your sensitive features are showing up among top key important factors of interpretability, that's a fairness issue. If you're seeing erroneous cohorts in error analysis that are based on like characterized by sensitive attributes, that's a fairness issue. So there are a lot of different clues about fairness that you can get with this dashboard already. But we have specifically plans in a very short term to bring Fair Learn capabilities, which is an open source toolkit for fairness assessment and unfairness mitigation, and have a dedicated section where you can pass your sensitive attributes and you can do a lot more sophisticated analysis. So definitely stay tuned for that, like very targeted analysis on fairness.
Well, this has been really amazing. Besmira, do you have anything to wrap this up, to center us, or am I missing anything?
I think the last things we want to send across is the fact that all this is open source. You can go on GitHub and be able to access it, to create your own components and co-create with us. As you saw, everything is modular. Everything, one can remove components from the workflow or add other components. So if there is a new component that you want to build together with us, we're open to that collaboration, include it in the workflow and see how everything works together. And this is part of a larger effort that is called Responsible AI Toolbox that will include not only the front-end parts that we talked about today with the dashboard, but a lot of other backend, machine learning backend capabilities that support each of these different dashboards together, enables mitigation steps, model comparison, and all this other spectrum of functionalities that we hope to bring together for everyone out there.
Well, this is fantastic. I'm going to put a link down here. This is where you want people to go, responsibleaitoolbox.ai, to learn more about this. Am I right?
Yes. Yep, responsibleaitoolbox.ai.
Fantastic. Well, my friends, this has been simply amazing. We've been learning all about Responsible AI Dashboard, a one-stop shop, literally, because we went through all this stuff, one-stop shop for operationalizing responsible AI in practice. Thank you so much for watching, and hopefully we'll see you next time. Take care. All righty. Hello, my friend. That was awesome. There were some questions in there, but I think they were like why it was going on. One of them was from your Jesh. Do we have some extra indicators like lower is better or higher is better, or do you just cover and see the numbers and figure it out? And because it, like, just to give some context, we had like error analysis, then we had data analysis, then we had the model and the data analysis, and then we had just the data analysis as well. Did I break this up well? And what kind of things can people do? And this, I know this is super free form, but your thoughts?
So something new that is integrated in error analysis in that component that we didn't have a chance to talk about is the fact that we now support also different metrics. And for some of them, the higher is better, the lower is better. For example, in the demo, Mehrnoosh focused on error, and for that, the lower the better. That's why that gradient of the red color increases if there is more error. But for things like precision and accuracy that one can just directly pick in the component, then you see a gradient of green increasing if the accuracy increases. But at the same time, we want to do a lot more on accessibility and being able to show these types of indicators more, in other forms and not only on color.
So the answer to the question is yes, you can do a ton of stuff. It just depends on what you're looking at. So here's a question that I was like, man, I should have asked this before. What does a workflow for someone building an AI model look like with responsible AI kind of baked into the process? Mehrnoosh, what do you think? I know I'm springing like questions on you here.
That's actually such a great question, and we think about it very deeply just because we plan to grow that ecosystem and kind of like contain an end-to-end ecosystem of a machine learning lifecycle and bring different considerations. So of course, the very first stage is problem definition. So you have to specify the problem that you're working for, and you kind of specify whether AI is an appropriate solution to solve that problem for. And the very first entrance of responsible AI to the whole problem comes from that problem definition. For instance, if you use the arrest rates of different neighborhoods to kind of like predict the safety score of that neighborhood, you are entering some dangerous form of societal biases in your AI, because we all know that the policing practices across the United States might be very heavily correlated with the different neighborhoods or different ethnicities living in different neighborhoods. So that is not a good indicator. Just arrest rate is not a good indicator for a crime rate of a neighborhood. So that's where a bunch of best practices and consideration comes into the play. Then you go to your data preparation and data understanding phase, where you usually wrangle your data, improve your data, get rid of the missing data or kind of like fill that, etc. And that's another area where you want to make sure that you are having enough representation on all different cohorts, specifically the historically discriminated against cohorts. And so that kind of responsible exploration of data that we kind of like try to bring with our data explorer module in this dashboard is another facet that you have to explore. And then you go to your model training phase and you train your model before deploying that model out there so that it starts impacting people's life. That's where evaluating the data, the model, and understanding how it is making its predictions to stay away from treating it as an opaque box or black box system comes into the scenario, which this dashboard actually could be quite helpful for that, because it helps you understand your model better, figure out its errors and any type of other type of fairness issues that are occurring there. And once you go ahead and deploy it, which means that you create an endpoint for it and you deploy it in a bank or hospital or you name it in your specific industry, then that's where we have to ensure that we have enough monitoring practices in place, because we all know that sometimes data over time changes and the model that you have trained on historic data are not applicable are to the data that is occurring in today's reality. And that's what is called data drift, where the data distributions and characteristics change. And so you have to monitor for that. And also you have to monitor for scoring time expandability, providing explanations of how the model is making its predictions at the runtime, same as fairness analysis, etc. So that's in very short form is the end-to-end from defining the problem to deployment and monitoring, and then getting user feedback and kind of like redoing this cycle as many times as required in order to ensure there are no harms on end users and humans.
So it looks like it's something that you think about throughout the entire process if you're doing it correctly. Am I getting this right?
That's absolutely true. And the danger with responsible AI is sometimes people think about it as an afterthought, but the reality is that's why, for instance, at Microsoft, we really invite other companies to also join in terms of raising the diversity and bringing diverse stakeholders to the room, because when there are diverse stakeholders in every single stage of ML lifecycle, that's where you can put these different guardrails and best practices and tooling in place to ensure that your whole model lifecycle is fair, reliable, transparent, as much as you can do it.
I mean, like I said, this is really, really cool. Now, here's a question, and I didn't, like, this is all live, so I'm just asking. Like, what I was seeing is that this is really good for tabular data. But what if you're getting into, and I don't know if this tool will do it, but how do you work with data that's, for example, like vision or speech? Besmira, your thoughts on that?
Yeah, so this is actually something in our pipeline. The secret to be able to handle this rich data types, vision and language, is actually having handles on them. So the same handles that we have in tabular data, like the features that people understand what they are, we need to have the same handles for vision and language. And while for language, somehow we do have those handles, like we have a vocabulary, we have words, bigrams, n-grams. So those things can be figured out, and topical interests and characters. For vision, we have a very recent work actually that was published at CVPR this year, where we extract these handles from vision data that are interpretable to data scientists and people in overall. And these talk about, structures in the image, like texture or objects that are present in the image, and maybe topics in the image that we can then leverage in error analysis, or even for interpretability reasons, to see how error correlates with these particular features. Now, again, this is something that we haven't integrated yet in the tool. We're taking this step by step, but I wanted to say that there is hope as long as we're able to extract these features.
Got it. So it's like that you have the actual asset, like a WAV file or an image, and then you have metadata over the top that then you can use to do, like, for example, error analysis or distribution of data. Am I getting that right?
Yeah, and actually in practice at Microsoft, many teams do collect this metadata explicitly when it matters, especially for fairness issues or for reliability issues. For example, they extract metadata on when a large user study is conducted with people in the lab coming in, trying new technology like HoloLens and things like that. Then all this data is documented so that we really understand what works and what doesn't in the new technologies that we're building.
And that's super interesting because at collection time of the data, you can add some very good properties. Like, for example, let's just say your speech model doesn't do well with certain kinds of accents. Beforehand, you can put down this person is not originally from the United States or originally doesn't speak English. It's their second or third or fourth language. And just having that tag alone in error analysis will tell you all our errors are coming from people that have accents. That's a problem. We need to fix this particular model in that case. Is that a good
That's
example?
exactly how we are using error analysis at the moment for vision data and for videos and audio. Yeah.
That is cool. All right. So here's a fun question. How should I, this is a good question in general. How can I join Microsoft Research if I don't have past experience, but if I don't have less experience in terms of years, but experience in AI, ML? Is there a way to join Microsoft Research without a PhD?
There is, actually. So there's very many different layers to Microsoft Research. I'm a big fan of the internship program that we have if folks are registered in a school program. We have an awesome undergrad program for folks that just want to get into research. Like, they may have never done research in their life. They may be just pursuing their bachelor's degree, and they want to see if they like it, if they don't, and work with researchers. So there is an excellent program for that. There is a program for people who are currently pursuing a PhD. And then there are roles on research engineers that do not necessarily have to have a PhD. I want to advertise two positions that we have on responsible AI. So one of them is actually in the FAE team in New York, led by Hannah Wolof. That is a close collaborator to us. Yeah. So take a look. And those are particularly focused on fairness. And then another position is in the Ether committee, which is the AI and ethics committee at Microsoft that oversees many of the efforts that we are working on. And they're looking for a research software engineer.
And I just add that I have publicly posted about all these 4 opportunities, 3 under FATE and 1 under the Microsoft Research on the large language models and NLP. So if you check out my LinkedIn, you will see those positions and you can apply.
Yeah, and I actually shared Hannah's stuff as well. My advisor when I went to school actually works at MSR in New York, and so they work together. So it's kind of cool. I saw him one time, and I was like, "Oh, you were my professor." And I found research to be basically a trail of tears where the output has to be some kind of writing.
Or tools.
Trail of tears.
Or tools.
What's that?
Or tools.
Or tools.
Libraries.
Yeah, I worked on one problem for an entire year. And I remember re-implementing what's called a QP solver, a quadratic program. It was a quadratic programming problem. And I implemented it in MATLAB, in Python, in something else, in Java. I don't remember. And I go to my professor. His name is Hal Dalmay. You can look him up. He works at MSR.
Yeah.
And I go, "Hey, Hal," because he didn't want me to call him Dr. Dalmay. He's one of those guys. And really cool when I say that. And he's like, you go, "Hal, this isn't working." And he's like, "Cool. Let me know how it turns out." And it turned out it's something no one had ever done before. And so it didn't work. And then one of my partners, we wrote something on it to back off. But this was many years ago when, deep learning wasn't a thing at the time. It was SVMs were all the rage. All right. So just to finish up, final thoughts, responsible AI, any final parting thoughts from both of you? Mehrnoosh, we'll start with you.
As you noticed, this tool is an open source tool that we are also going to integrate within Azure Machine Learning very soon. And we always love to hear from the community in terms of GitHub issues and feature requests they have. If there are any case studies that they want to engage with the tool in the open source or on Azure Machine Learning, or whether they want to bring their own component and kind of like stitch it into the other lifecycle and kind of like contribute to it from there. We love that, and we are always welcoming those. And so please stay in touch with us. Go and check out our open source repository and send us GitHub issues, send us PRs, and join the growing community of people who deeply care about responsible AI tools in practice.
Yeah, and I think we all should, right? Besmira, over to you.
I want to take this opportunity to also thank everybody that was involved in this project. You will not believe, Seth, how what a diverse set of skills is needed to complete this project, like from design to UX research to engineering to machine learning research to marketing. And sometimes we forget about all the diversity that is needed and focus only on engineering, but as you saw, a lot of it is on the front end, focused on users, and we take that into account.
Well, this has been amazing, my friends. Thank you for being with us, and have a wonderful rest of your afternoon, day, wherever you are.
Thank you, Seth. Have a great rest of the day.
All right. Take care. All right. So let's get some people out of here. All right. How about them apples? Besmira and Mehrnoosh, they're awesome. Like I said, this responsible AI stuff is pretty cool. Once I started doing AI things, and then I started recognizing like how cool it was, I started really thinking about like how do we inject responsibility throughout. Janny Scoo. Oh, hold on. Janny Scoo, number 7. Responsible AI, rock, paper, scissors, huh? I gotta turn that down. Responsible AI, rock, paper, scissors. I know, we should try that. I wonder, oh, jeez, my watch AI always thinks I'm talking to it. You're not as important as you think, watch. So yeah, thank you. And again, if you have any questions about that, that would be glorious. I'd love to see if I can answer. If I can, I'll ping Besmira and Mehrnoosh. They're fantastic people. All right. So let's share my desktop again. Doop. This is the stuff we're doing. Here's the cool thing. So if you're a .NET person, if you've ever one of the PMs there loves building machines, and he pinged me and he's like, "Hey Seth, I've got a GPU. Do you want me to build a machine for you?" And I was like, and all I had to do was pay for the parts because he just loves doing it as a hobby. Let me show you the gloriousness that is my machine. Okay, are you ready? Are you ready? Are you ready? Here we go. I'm going to open the task manager. Task manager. Boom. My mic keeps moving. Take a look at this goodness here. Let me go back to my task manager. Are you ready? Performance. Boom! Look at all those beautiful processors just doing their job. Well, they're logical processors, right? 16 cores, 32 logical. 1, 2, 3, 4, 5, 6, 7, 8, 24. 8 times 4, 32. 2, 4, 5, 6, 7, 8. Yeah, 32 logical processors. 32. Here, look at this. Look at this. You know how when you open a browser window and you're just like, why is this taking so long? It's because the browser just sort of like, it's like, oh, RAM, it just leans on the RAM, right? Look how much RAM I got. Boom. Yes, I'm gonna make this as big as I can. Well, what? How cool is this? Yeah, I'm doing all sorts of things. It's just like, you know what? I'm just using 18 gigs of RAM. It's got all sorts of room. It's got like 100 gigs of RAM left to just sit around and lean. We should do something memory intensive. Like I love it when people are like, hey, you know, I have a big data problem. I'm like, how big is your database? Oh, 5 gigs. So you mean it can fit in my RAM 60 times? Not 60 times. That was wrong. 5. What's 5 into? Let's do 5 into 120. 128. Right. Obvi2 here. 28 here. Then 5. 25 times. It's not big data. It's not big data. And then my disk, super fast. SSD. Might as well be my other RAM. All right. So that's my new machine. I'm pretty excited about it. Let me open it again so we can just, I think we should just stare at it and it's beautiful. It's so pretty. Yeah, memory consumption. Nothing. Here's my Ethernet though. Let me dial up to the internet here real quick, so I can get some more speed here going. There we go. There we go. We're connecting. Now we're connected to the internet, so our speeds. Jay, yes, it's a new machine. Yes. Look, hold on. Jay wasn't here. I gotta put some like 32 logical processors. Jay, check. Need some RAM? How about 128 gigabytes? Let me zoom in here because I'm not there. 128 gigs of RAM. SSD. Transfer rate. Boom. 500 Ks per second. So good. Did I mention that I got a new GPU? Huzzah! Thank you to Damien Edwards, by the way, who built this for me. Such a nice dude. I showed up at the office. He's like, man, I had a fun time putting it. The GPU was so large, we had to get a different motherboard. Not gonna lie. In fact, let's see. Let's see if I can find the tweets. The tweets here. The tweets. Where are you? Where are you? Hold on. Where is this? Oh, and then I tweeted about NFTs and you know. Psst. Psst. What do we got? What do we got? Here we go. Here we go. If you folks know who Damien Edwards is, here he is. These are all the things. Look at that. Look at this. Look at this beauty. Look at this beast of a GPU that he got me. Yes. Look at that. That's his hand. And he's a big dude. I mean, tall wise. Big dude. Look at that. Let's keep going. Let's keep going. Look at this. I mean, does anyone want to put their thoughts into the comments here? Because, I mean, this, to me, it's changed my life. I can open a browser window with confidence. I can run a machine learning job. And not have to wait for anything. It's glorious. Hold on, there's more. There's more. There's the CPU. Look at that. Look at this goodness. My processor. What is this? Yes. So good. Look at this. Thank you to Mr. Damien Edwards, who is a glorious, wonderful person. Look at that. He built it for me. ResNet 1024. Here we go. 20 billion parameters. Oh, there you go. All right. So one of the things about that, though, look at this. Look at this goodness. One of the things about that is I don't know if I set up my machine all the way. So we're going to see if we can even run these jobs. Here we go. Loading the Azure Machine Learning extension. Here's our thing. There you go. Lol, won't upgrade to Win 11. Hardware not recent enough. Oh. Well, Jay. Mine is. Thanks, Damien. Oh, and like, I got an Elgato card in there, so my camera is going directly into the board. My DSLR into the board. Into the board. Yes, into the board. So, yeah, that's cool. All right, so let's see if this is any faster. Let's see if it even works. Okay, so we'll bring this up. GPU. I want to see what you do. I upgraded my PyTorch Lightning thing. So you have to add this now. So we're going to go investigate what that means. Oh, here we go. Here we go. All right, GPU. What you got for... Oh, jeez. Oh, goober. CD AI. Boom. Now we can do it. All right, here we go. Here we go. GPU, do your thing. Do your thing, GPU. Okay. Oh, look at that. Here we go. Booyah. Look at the speed on that. Look at that beautiful training footage. Look at that. Memory of the GPU. And by the way, I'm not slowing down and I'm on the same machine. Oh, it's getting hotter. It's getting hot in here. 59 Celsius. 60. Look at that. This is cool, right? GPU. You can see it doing the work. Oh, we need to figure this out. Done. I don't even know how long it took. I just like watching it do it. Wasn't that cool? And now the temperature, it looks like it went up. Oops. Only using 4%. How high did it get when? Let me do it one more time. How high did the utilization get? 5, 13, 67, 65. Oh, nice. Oh my goodness. I'm looking at this the first time with y'all, so it's glorious. But it's getting hotter in here. This is really cool. Look at this. It just takes the space. Look at the RAM. It went up to 23. The disk. Look at the CPU. Oh, multi-threaded or what? This is probably for fetching things and converting it. Look at this thing hum. And I can still look at things in a browser. It's bananas. Bananas. And I'm streaming in the browser too. So am I getting laggy at all? Going back down. Going back down. Go back down. This is cool. GPU's done. It's a little spike there at the end. I wonder what that's all about. But you can see it's just, I don't know. It's cool. Like I was using a bunch of CPUs, but not a bunch of other ones. So everything else was still kind of just working. There you go. All right. The other thing that I wanted to look at is ml.azure.com. We left off last time, if I remember. We decided to just forget to try to do the thing. Really awesome. No lag. There was no lag when you were watching. Yes. So usually when I'm running these things, there's kind of a lag, right? Because it was running on my laptop, which incidentally was a good one. But that was cool, right? I thought that was cool. So let's go back here and let's try to remember what we did here. So we decided to go with the VGG19 and we decided to see if we can get an endpoint working. Here it is. This is the one we built. November 12th, I think, was the last time. Wow, that long? It's like a month. Looks like the deployment failed. That's weird. Let's go to deployment logs here. Oh. We can fix this. So the metadata is complete, and then when we try to load the timestamp, it didn't work. So Rochambeau endpoint. This one didn't work, so we can't test that. All right, so let's see what we can't do to fix it. So it looks like the timestamp didn't work. Let's go to the model here. There should be a Rochambeau model. Version 2. Custom format. Let's look at the artifacts here. The meta should have a timestamp. Oh, jeez. Just want to look at it, okay? Just want to look at it. Yeah, that's why it's broken. When we did the model registration, when we did a model registration, we forgot to, this output's not right. So let's go to outputs here and let's see what we're actually outputting now. Yeah, we're not putting a timestamp out there. Why not? Okay, so what we're going to do, yes, lag or no lag, there is no try. Yes. So it looks like we have a problem with this deployment. The scoring file, why doesn't it like this? Inference schema decorators, Onyx runtime. So we don't have that in there. That's okay. We'll figure this out. It looks like, yeah, this timestamp. It's looking for a timestamp that doesn't exist. So let's go to the trainer. And let's figure out where we do that. Rochambeau, let's go to the model because the save is in the model. There it is. No timestamp. Derf. Timestamp. Boop, 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 boop. And let's get a good timestamp that won't burn us. You know what I'm saying? No, that's not what I want. How do I do timestamps here? Timestamp. I want to make it like a string, you know? So like datetime.now. Date time dot now dot ISO format. Okay. There you go. That's what we needed to fix. What? Not a Git repository. Oh no. Oh no. This is stinky. When I copied things over, it didn't copy over correctly. What a bummer. All right, let me look at my projects here. I wonder if I could cheat. Oh, good night. How do I fix this? Oh, that is terrible. I did not save my .git folder. All right. We're going to cheat. Okay. Rename. Thank you. Now we're going to go to github.com. I think it's AI advocates Rochambeau. Okay. Let's check it out. Check out. Boop. Oh, I'm a dummy. It's git clone. Is it git clone? I don't remember. Why don't I remember how to do anything with git? I think it's git clone. I haven't done anything in a while, huh? Git clone. There you go. Gosh, I don't know how to do anything right now. This is embarrassing. Just swigging my drink. I wonder, why can't I see the .git folder? View. Show. Hidden items. There it is. Oh, of course it's. I just changed the name. Can I do this? Is this illegal? Am I breaking a rule? Oh, hello, Beldathas. Welcome. I screwed up my Git stuff, Beldathas. I'm so sorry. This is embarrassing. All right, let's go to Rochambeau. CD Rochambeau. Git status. Okay. I think we're good. I just hacked it all. I don't remember doing any of this, but I think I did do it. Timestamp and this one. Log file version 2. Okay. Here we go. Oh, okay. Okay. Git status, git add dot, git commit -m, corrected timestamp deploy issue. Git push origin main. All right. Let's see if our GitHub actions are going to work. I think I broke it. Oh, shoot. Why is it doing it? Oh, it's doing the static web app and the CI/CD. Okay. Okay. Look, the magic is happening. Look at all this goodness. I know. So what happened was new machine, right? And so I got up this morning. I'm like, oh, crud. I got to make sure all the code still works, or else what am I going to show? And so I showed up and I installed, and you know what I'm going to do is I need to do like an episode where I show you how to install PyTorch on Windows and how I'm using it. Like I want, would people be interested in looking at how I set all this up and why it looks the way it looks? That might be interesting, right? Because I mean, I really like the way this looks, and it feels like super crispy. I wasn't even there. It feels like super crispy. You know what I'm saying? Like everything looks super nice. I can tell you. It should have. Conda activate. Why? I don't know why. I didn't do it the right way. Let's delete this. It should. There you go. You see how it all activates? I know what's going on all the time. Yeah, everything's good. I maybe I'll do a show where I show how to do all this. Okay, so let's see where this is at. Checking the endpoint. I think for us, this endpoint is garbage, so let's just delete it. Nice. So let it delete that. So it's not working. This is checking the endpoint. It's running the machine learning experiment here, like we did before. Then it's going to register the model. Then it's going to deploy the model. Oh yeah, no question. But I've done it so many times that it's actually in my head I have this really fast workflow, right? You got to install CUDA, and then you got to install cuDNN and that funky like drop folders into a place way. But maybe I should do a video on it, right? Or because one of the cool things, and I don't know if y'all know this. Here, let me open my camera app. Is this here is a different computer. This is how I keep track of the time and what's going on. But this is a laptop that's literally like that's literally right below me, and this means that I can actually live stream and show you like how to set up a machine. How to set up a machine. Oh my goodness. My friend Adnan knew. Oh man, he remembers old school. So I've known Adnan now nigh a decade. Nice dude. Machine learning. He has a doctorate in AI type stuff. Really good dude. Has a number of wonderful books. So make sure you go look those up. I wrote a library called New ML, New Machine Learning for .NET. But anyways, what I was trying to say is I can totally like go onto this machine and not like screw up the stream and install things from the beginning. You know what I'm saying? And so that might be a good. Maybe we'll do one of those. You know, because like I said, this new machine is enabling me to do all sorts of cool stuff. And then have I seen Torch TensorRT? I have not. I should look at that myself. But yeah, this is cool now. So now I can, for example, show people how to install things from scratch, you know, and do restarts without the stream like ending. And so this is a cool little new setup thing that I've got going on. Let's go back to the actions here. Looks like the Rochambeau.ai deployed. This thing, I think this one last time took like way too long. It looked like 50 minutes because if something was wrong. But wow, that one took 3 minutes. Oh no. I'm looking for Rochambeau CI/CD. Yeah, that one took a long time. I delete them because I don't need them. But this will take, I don't know, hopefully it'll be done by the time we get to it. But I actually have another endpoint here that I think is like exactly the same that we can use in the meantime. Oh, it's still getting it wrong. It's still getting it wrong. I probably need to give it more data. And the other thing I want to do is I want people to be able to go to this. By the way, the website, if you want to see it, it's Rochambeau.ai. It doesn't work all the way, right? Let's look at Camlink 2. It's looking at my screen here. Look at that. Is that cool? Beep, beep, beep. On the screen. This is the one I use for. And I got a new screen here that's sideways, which is really cool. So this is the one I use for rock, paper, scissors. All right. So maybe we'll just use this thing until the other one deploys. GitHub.com. We'll watch this one. This is going to take like 30 to 40 minutes, to be honest. Oh, good. You'd be interested. Yeah. Yeah. I really want, like, I think that's one of the things that I just haven't seen a lot of videos on. And maybe I'll make one live and then I'll edit it post to make it more succinct, you know, because the live one will just take how long it takes. I don't know, take maybe 20 minutes. But I need to flatten this machine, you know, and do all the things. Okay. Like I said, this part, how long did this take last time? Let me go back to the actions. Rochambeau. Yeah, so this part took 7 minutes. This part took 1 minute. This part usually takes probably 10 or 15 minutes if it's not broken. So we should be in 7 minutes see the experiment done. It should register the model with the timestamp, right? Because this trainer is asking, I'm sorry, this scoring file is asking for the timestamp. Yeah, let me see. When it loads it up, yeah, it's getting the timestamp too. Yeah. So did I spell? If I spelled it wrong and started this whole thing, I'm gonna be PO'd. Oh, same thing. Oh, whew, whew. Here's it. Torch tensor. Yeah. I mean, what was TensorRT? Let me look it up here. TensorRT. TensorRT. Okay. Is it SDK for running it started? I've never tried it this way. How does this work? How does this work? Okay. PyTorch TensorRT blah blah blah. What is TensorRT? Is an integration for PyTorch that leverages inference optimizations to TensorRT on NVIDIA GPUs. How does it work? Lowering Torch script module conversion. Oh, I see. It's a it does replacements. Oh, see, because these things are paired so often, if it does a convolution and a ReLU at the same time, then it's definitely going to be faster. Support for int 8 for quantization, I'm guessing. Yep, there it is, quantizing. Sparsity is related. I don't have an A100 GPU. Let's go buy one. Products. I wonder, A100. How do we buy one? Enterprise and software ready. Deep learning. I wonder how much an A100 costs. NVIDIA A100 for PCIe. I wonder, how come you can't buy them? NVIDIA. Products. No, I don't want push notifications. Where do I buy an A100? Is this even possible? I have a 3080. Not a TI, just a regular. I can't buy one. How come you can't buy one? Products. Graphics cards. Nope. Can't buy one. But anyways, we were looking at this. Sorry. So scrolling down here. Interesting. Okay. I have not installed it, never tried it. Efficient net. Comparing throughput of native PyTorch with Torch Tensor. Oh, well, I mean, but like, if this is a CPU and this, yeah, it's not going to even be close. Okay. Yeah, I should look at it. That's a good question. Okay. Let's go to actions here. That's done. It should be, oh, wow. Why is this? Oh, this is taking a while because it hasn't done it in a while. And so it basically has to rebuild, unfortunately. That sucks. It has to rebuild the image. And so this is going to take a while. What a bummer. Totally forgot about that. So this is going to take a lot longer. Sorry about that. We can use the other one for testing. Okay. All righty. This is interesting. Let's take a look at the Onyx TensorRT. I need to learn more about this. I've not in Azure ND A100. Yeah, there's A100s on Azure, but you have to like they don't give them to everybody. You have to like ask for them, because we don't want people like Bitcoin mining and stuff. What a waste of compute. Okay. All right, so back to this goodness. We fixed this. So now that we're writing this out, it should go out. Now let's go back to our website here. So let's close all of these windows. Close. And let's take a look at our pages here. There's our index page. This sets the media track settings. And then we send this back to the predict. And let's go to the API here. And let's remember. I think it's this one. Yeah, predict. Yeah, remember we tried to do a bunch of stuff and it just would not. It would not work. So let's figure out how to post to this endpoint over here. We know this endpoint. These are clones of each other. This is just something that I was doing for something else, for a different demo. Yeah, it looks like it's got two things in there. Test. It might get things wrong, but that's okay. I might have to move it over because I think it shows our key in there. I think we're just making a request. Let's take a look at what it expects over here in the AI. So for those that are wondering, so this website that we're building, Rochambeau.ai, we want to be able to do rock, paper, scissors, and then like send it directly to the AI so it can tell. So if I say submit, right, there's going to be an error. There's going to be an error, right? There's something's wrong. Oh, wait, maybe it is doing something. Oh, yeah. So the reason why it doesn't work, or maybe, wow, is it working? Yeah, the reason why it doesn't work is because we had to squish the image and we were doing some funky. I just got tired of it. You know what I'm saying? And when you're saying get tired of what? Well, this API, when we post an image, we had to do all sorts of like convert to tensor, and it was just. I mean, I just don't want to do it. I want to get rid of all of this and just call an endpoint. Do you know what I'm saying? That's all. I just want to take that all out. You know what I'm saying? I just want to call the back end, give me the thing, just be done. You know what I'm saying? So let me do this. I'm going to go full screen because I got to put some secrets in here. Local settings. Okay. Let's see. Endpoint key. And I will put the endpoint key here. You can't see it, so I'll close it now. And now we can go back to this computer. Okay, cool. All right, so I'm trying to remember how to read things here. Look at something I wrote. GitHub.com. Yeah, I did something similar. So maybe I'll just copy the code. Function.json. Oh, see, I need two things. Look at this. Look at this. Look at this. Holy cow. This is literally what I need. I need exactly this. I just need this. Glorious. Why doesn't it like this? Oh. CD API. Okay. So I just need to be like inference endpoint, inference key. I need those two things. So let me go back and do this again because I can't show you my secrets. I mean, I guess I can, but I don't want to. No secrets. No. Okay. So inference endpoint and inference key. Inference key, and then the endpoint is this. And the cool thing is I can change this later when the other one works, right? So I just changed that. Boom. Here we are. Very good. Okay. I mean, and let me just remind myself here. What can I send this scoring file? Oh, I can send it the base 64 URL. Let's see here. Let's close that. Let's go to the front end. Like I literally think I made like exactly the same thing. Source. Index. No, that's not what I want. Components. Elements. Let's go to, is there like a page or something? Where is this? App. Okay. Okay. Use state prediction, set prediction. Huh. Interesting. By the way, is this still running? Jeez. It's still running. So it looks like when I do this thing here, let's go to the, not the API, the API. When I go here, I'm taking the frame. What is the frame though? It's image data. Let's go to definition. Yeah, it's the clamped array. We don't want that. I don't want that. I just want the base 64 image. Because I think I made it so that it could do the base 64 image. So it looks like the frame comes in. It's of type string. Where do we set the frame? Yes. I know it's there. But where do we reference? Set frame. There it is. On the video, we do a set frame. On the video. So that's the component. Let's go to the component. elements, video, and then the set frame on frame set. What are we giving it? Oh, there we go. There we go. We're doing a to data URL, and that thing, where does that happen? Set frame. APA response is not right. We need to fix that. There it is. It's also on the video. So let's go to definition. This should be a string. On frame set, I think we just want to do a canvas. We draw the image. Yeah, it's just this. Control Z. Yeah. 320 by 240. Oh, this is smarter. This is actually smarter because it checks to see if there's anything there. Wow, look, past Seth is just awesome. There you go. So what this does is this will send. Why is this mad at me? Where's the madness? Oh, shoot. Oops. There it is. Okay, so that's good. This doesn't like it because it wants an image data now. And then what did we do over here? Just to remind ourselves here. Source. Is it index? No, it was app. App. Here we go. Here we go. This is, I think we need this because this is the same thing. Because our API, our return result is not going to be that. It's going to be this. And here it is. Look at this. This is all just done. What the heck? What am I doing? Why is this still kind of weirdly offset? Oh, this is right. What is this? There you go. Where do we use this? Okay. Okay, I think this is doing it. And this will now send to API predict, which is the right thing, with our options, which is a post. We stringify the image frame, which is a to data URL. It should work. All right, let's see where we are on the. Holy cow, it's 43. Let's see where we are with the. Still. Oh. It's still preparing. Oh, what a bummer. Still preparing. Yeah, this takes a long time when it's rebuilding the image, unfortunately. Sorry. Let's see this. Yeah, sorry. We'll just use the other one and then we'll. Dang, yeah, and this takes a while, so we're probably not going to make it there. But we'll use the other one to see if we can't get some predictions going. So let's see this. Swa dev start. Oh shoot, I have not installed this yet. Static web app CLI. Here we go. Okay. Tool, blah, blah, blah. Click start. Okay. Here we go. By the way, what we've just done is we've swapped out the back end to literally just call the endpoint that we made on Azure ML. That way I don't have to fiddle about with. So look at this. So basically the thing comes in, I get the image, I post it to the endpoint with the key, and then I send back the response. That's it. All right. So let's see if this works. Swap. I think I need to F5 on the back end. Yes. So this is doing Azure Functions. Cool. Yeah, we'll fix that later. And then over here, I do swa dev start. Oh, swa start dev. Okay. So let's do this here. And let's open it up over here. Okay, cool. So this is working. Let's give it some permission so that it can use my camera. Allow. Refresh. And then we want to do this. That's cool. That's right. Let's go over here and let's console out some stuff here. Here. Cool. So we'll console log out the prediction. Console.log red. Okay. Cool. So now did a fast refresh. So if I do rock, oh snap. Oh snap, it worked. Look at that. Hey, Sharafuddin, the question is, why do we need to use AI dashboard? Is AI enabled Power BI can do the same? Yeah, so the AI we're talking about responsible AI dashboard, which is a little bit different because it looks at statistics of the actual data and the model for machine learning purposes. So that's a good question. So it worked. Yeah, it worked. All right, let's see if it really worked though. Let's we have this entire object, this prediction object that we can use. So let's do this. Device selector, video, message. We don't need to no. 320 by 240. This was another thing that was looking a little. It looked clip. Remember? So submit. Oh, hot dog! Hot dog! All right, let's go over here. Let's do a paper here. Let's see if I can't click with the other button here. Hold on. Oh, jeez. Hot dog! What? Hold on, did I make it so I could use this space button? If I didn't, that was awful. Let's see. Where's the submit index.tsx? I think it's just a button. Button. Un bâton. Un bâton. Title, welcome to Black Bolt Beak. Oh, I think it's actually in the video. Is that? Yeah, there's the button. Oh, that's so lame. I gotta put like an event on the entire screen. You know what I'm saying? You know what I'm saying? Yeah. Okay. Okay, so let's do this. Let's do a div here. This is the message. So let's do this. Let's div we'll say prediction dot all right, we'll do that. And then we'll say UL, an ordered list, LI, prediction dot scores dot none. Oh, so. And then we'll say none like that. No. Paper. Rock. Pop. And then we'll take this thing. Paper. Rock. Okay. Here's another question. Responsible AI dashboard can be used in any .NET ASP Core version. So that dashboard is an open source thing. So you can go to Responsible AI Toolbox. So thanks for here. You can go here, Responsible AI Toolbox.ai. Here, let me just bring it up here so people can see it. Responsible AI. There it is. And you can learn all about like how to use it. It's literally like open source stuff. So feel free to go hack on it, dude. I'd love to see what you build with it. It would be. Oh, look at that! It's doing stuff. Set root folder. Maybe I'll do that later. Okay. So now if I do rock, it says scissors. If I do scissors, it says scissors. Let's see how confused it was about rock. No, it got rock. Paper. Holy cow! Look at that! I think it's doing it. What did I do here? I did something clever. Oh, here it is. I did a percent format. I think I did something here too. Oh, see, look, I was super clever about all of this. Percent. Look at that. Look at that. All right, let's see. Is this still going? Oh, jeez, Lou. You're killing me, Smalls. You're killing me. Still building the friggin' image. Are you kidding? That's why this stuff runs at night. I'm just going to deploy this real quick. Let's see if I was smart about the Azure Static Web Apps. Yeah, only these paths. And only these paths. Cool. Let's deploy it. Let's no, I don't want this. Don't want this. So we're done. Git status. Yeah. Git add dot git commit minus git commit minus m using AML endpoint for inference. And we're using the big daddy model or the big mama model, whichever. I mean, oh shoot. It's time for our walk-off music. Let's see if this deploys. This should deploy in a couple minutes, right? Here we go. Here we go. Hey, yo. Here we go. Here we go. Why isn't it doing anything? Refresh. Come on. 40 minutes ago. Oh, I got to push. Git push. Origin main. Here we go. Here we go. Static web app. Show me your business. Here we go. Here we go. We're shaking it around. It's going to do it. Here we go. And what I'll do is once we're getting into the Rochambeau endpoint, I literally just need to swap out the... Oh, shoot. I do need to add the secrets to the thing. So let's go to portal.azure.com. Here we go. Here we go. We can do this in 3 minutes. Yes. Consume. Here we go. Where is the Rochambeau.ai thing? I don't know. Resource groups. Hurry up, Azure. Hurry up. We've only got 3 minutes. Rochambeau and there's the Rochambeau thing. Let's go to the configuration. Production. We're going to add some secrets. What secrets? API. These secrets. Inference endpoint. Copy that. Beautiful thing. Okay. Then we're going to add the inference key. Boop. Inference key. Here we go. Copy that. Boop. Okay. Save. You can see them hidden here. We'll go to the... Oh, jeez. What? Browser list, can I use that? Please. Cannot read property of prediction. Oh, I know why. I know why. Because, what a bummer. I have to fix this. All right, my friends, we're not going to make it. It's because this thing starts out as a null, which breaks this thing over here. I guess if I do a question mark, maybe it'll work. Question. All right, my friends, we are basically out of time. Hey, you know what? I'm not streaming on Learn TV, so I can go a little bit longer. I can go a little bit longer. I have a minute of music left. We'll go 30 more seconds. And if it doesn't make it, that's okay. Just go to rochambeau.ai to take a look at it. We'll let that sort itself out. My friends, it's been a pleasure being with you today. As always, we got some stuff done. Now I'm just deploying it a little bit. I'll see you in a couple of weeks, I hope. By the way, go to responsibleaitoolbox.ai to learn all about that cool stuff that we just talked about. It's been a privilege and a pleasure. Next time, we are going to have, let me go to my here. Next time, there you go. Join us Friday, December 17th for Automate Custom Vision Models Creation with Auto ML for Images with Surge. I think I'm doing that one, actually. So I'll see you next week, I hope. Thanks so much for being with us. Thank you so much for spending some time with us on the AI show. It's a privilege and a pleasure to be with you. If you ever have any questions, make sure to reach out to me. Take care.